I welcome you all for this course on signal and image processing using MATLAB. Myself J. Prabin Jose. I completed my UG degree from St. Xavier's College of Engineering, Nagarkovil, and I completed my ME degree from Mefkoslang Engineering College, Sivakasi. Currently, I am working as assistant professor in Kamaraj College of Engineering and Technology. In this series of course, I am going to explain you how to implement signal processing and image processing concept using MATLAB. I feel this course will be very useful for the students, those who want to learn MATLAB and those who want to do their project in signal processing and image processing. So, in the series of course, we will see how to implement convolution using signal processing, how to implement correlation using signal processing, how to implement DFT using signal processing, how to implement FFT using signal processing. So I will try to teach some algorithms without using inbuilt functions. So in MATLAB, you can see a lot of inbuilt functions to do many complex operations. But in this course, we will try to do some code without using inbuilt function. For example, convolution operation without inbuilt function, correlation without inbuilt function, DFT without inbuilt functions. So this is the in the first video lecture, we'll see introduction to digital signal, image and MATLAB. So, what do you mean by a signal? How will you define a signal? A signal is defined as any physical quantity that varies with respect to time. So, this is the definition given for signal. So, there is another one definition is also there for signal. So, we can define signal as any dependent quantity depends on an independent quantity is also called as a signal. So, any dependent quantity depends on an independent quantity is also called as a signal. So, normally how will you represent a signal? So, normally we can represent a signal as A of t or X of t. So, we can represent the signal as I am going to draw a signal here, sample signal. So, A of t I can write this. So, the amplitude of the signal is varies with respect to time. So, I am for x-axis I am putting the amplitude value, time value, and y-axis I am using the amplitude value. So, normally a signal can be represented as A of t, and we can define any dependent quantity depends on an independent quantity. So, here which one is the dependent quantity? So, this amplitude is the dependent quantity, dependent variable, and this time is the independent variable. So, any dependent quantity depends on an independent quantity is also called a signal. Okay. So, so here we defined any physical quantity that varies with respect to time. So, example for physical quantities: amplitude, temperature, pressure are the examples for physical quantity. So, signals can be classified into 1D, 2D, 3D. Now, we can define what do you mean by 1D signal. So, a 1D signal, one-dimensional signal, we call 1D as one-dimensional signal. So, 1D signal, how can you define 1D signal? So, any dependent quantity depends only on only one independent variable. So, any dependent variable depends only on one independent variable. We call it as 1D signal. So, for example, here this x is the signal, x of t is a signal, x is the dependent variable, and it depends only on one independent variable, time. So, this type of signal we call it as one-dimensional signal. And the real-time examples for one-dimensional signals are ECG signal. You can say ECG, then electroencephalography, EEG, speech is the best example for signal. Speech signal are the best examples for signals. Speech, ECG, EEG, EMG is an example of 1D signal. Now how we can define 2D signal? So a 2D signal, how we can define a 2D? So two-dimensional signal. So any dependent quantity depends on two independent variables, we call it as a 2D signal. Any dependent quantity depends on two independent variables, we call it as a 2D signal. So the best example for 2D signal is an image. Image is a 2D signal. Normally we represent the images f of x comma y, and this f represent pixel value or intensity value. Normally we'll represent images like this, 112, 220. So this we call it as the pixels of an image. There is nothing but function, and x comma y are the coordinates of your image that varies from 0 to m minus 1, and y varies from 0 to n minus 1. So these are the coordinates of the image. And 1D signal in MATLAB, how we can represent this 1D signal in MATLAB? We can represent 1D in the form of a vector. So A equal to a square bracket of some value, so 1, 5, 6. So this indicates that 1D signal contains a single row and multiple columns, or it may be multiple rows and single column. So the dimension of 1D signal may be 1 cross n, or otherwise we can say it as n cross 1. So this is the dimension of a 1D signal. So dimension of a 1D signal. But in case of 2D signal, the dimension is given in the form of m cross n. So m cross n. That is the best example for this 2D is matrix. So normally we represent image in the form of matrix, and all these 1D signals, speech signal, ECG signal, EEG signal, in the form of vectors. That is one dimensional signal. Then 3D is nothing. 3D signal, any dependent quantity depends on three independent variables, we call it as 3D signal. Normally we can say 3D signal as f of x comma y comma t. So that is the best example for 3D signal is video processing. So here the beauty of this course is that if you are good in signal processing, you are good in image processing. If you are good in image processing, you are good in video processing. The algorithms what we are learning in signal processing can be used in image processing and can be used for a video processing. Video is nothing but continuous images. If you run thousands images, you will get a video data. If you want to do video processing, you have to convert the video into images, and then you have to apply your algorithm. Then you have to convert from image to videos. That is the process you have to follow. So the best example for an image is defined as 2D function f of x comma y, where x and y are the spatial coordinates, and the amplitude of f at any pair of point coordinates x comma y is called intensity or gray level of an image at that point. So these are the different types of signals: analog signal, discrete time signal. So all the real time signals are analog in nature. By using sampling process, you have to convert your analog signal to a discrete time signal. Then by using quantization and encoding process, you have to convert your discrete time signal into a digital signal. Then periodic signal. If a signal repeats the particular period, we call that signal as a periodic signal. Otherwise, we call it as an aperiodic signal. Energy and power of the signal. Even and odd signal. So the condition for even signal is x of n equal to x of minus n. We call that signal is an even signal. And the condition for odd signal is x of n equal to minus of x of n. In causal signal, the causal signal is defined for n greater than or equal to 0. And non-causal signal is defined for both n greater than or is equal to 0 and n less than or is equal to 0. So I'm not going to explain briefly all these things. We directly see how to do the programming part. So this is the represents analog signal, and then we are representing the discrete time signal. Then by using D to A converter, we can get your analog signal. So then what is digital signal processing? Why we have to learn this signal? Why? What is the reason for learning signal? So signal conveys information. So to get more information from the signal, we have to process the signal. Then why it is digital? So the memory requirement to store analog data is very, very high. So we go for digital, and all the processing device in our day-to-day life are digital devices. So if you want to process your signal, you have to convert your signal into digital signal. So this is a sampling digital to analog conversion process. So examples, applications of signal processing you can use in radar and sonar for target detections. Biomedical, we are using for to analyze ECG signal, EEG signal, and electroencephalography signals. Then in speech processing, noise reductions, then we can use we can design a speech recognition system, synthesis of artificial speech systems, telephony signal systems that we can use it, encoding and decoding. Then image processing, we see some image processing based applications, content based image retrieval, image enhancement, image compression. Then biometric identification systems such as fingerprint, palm print, face, signature. It's all applications you can do by using MATLAB. The target recognition using image processing, the traffic monitoring system using image processing, face detection system using image processing, facial expression recognition system using image processing, hand gesture recognition using image processing, sign language recognition using image processing. So we will see all these applications in MATLAB. So then here is best example is video processing based human activity recognition system, then character recognition system using image processing. And these are the various project contests for the students. So if you have good innovative ideas, you can participate in this contest, and the winners will get more than 1 lakh rupees as cash prize. So earlier days projects based on hardware based or either go for software based. In the current trend, you have to know hardware as well as software. You should know how to interface your hardware with your software. Then you have to work on IoT. That's a current trend, current scenario. So next lecture we will see, in my next lecture we will see introduction to MATLAB and some basic features of MATLAB programming. Thank you.